Introduction to amino acids. Amino acids contain a basic amino group, NH2, and acidic carboxyl group. Alpha carbon in amino acid is the carbon that is attached to NH2 and the same carbon is attached to the COOH. Amino acid has the compound which has alpha carbon, NH2COH, one hydrogen, and attached to G. So this G can be R group. This G can be R group. Anything can be G. Amino acid is the carbon that has these three, NH2COH, hydrogen, and G. G can be any R group. These are the classification of amino acids. These are 20 common amino acids. We can classify them into neutral nonpolar amino acid, acidic amino acid. Here, if you look at the amino acids, they are in their zwitterion form. I'm going to explain in detail what is zwitterion. So this the carboxyl group part, and this is the amino group part, and this is the alpha carbon, one hydrogen. The G here is hydrogen. And if you look at this one, example for acidic amino acid, this is the alpha carbon, carboxyl group, and here amino group, and then this is H, and this is R or G. Okay, so different types of amino acid has different G, different R group. It can be anything as long as it has alpha carbon, carboxyl group, amino group, and hydrogen, and we call it as amino acids. The IUPAC name as amino derivatives of carboxylic acid. Why carboxylic acid? Because when you compare the functional group of carboxylic acid, functional group of amine, and this is carboxylic acid, carboxyl group, and amino group, the carboxyl group has higher priority than amino group. If you refer to the priority table, functional group priority table, carboxyl group has higher priority than amino group. So that's why it is named as amino derivatives of carboxylic acid. Carboxylic acid will be the parent. First, you have to identify the longest carbon chain contains carboxylic acid functional group. So here, select the longest chain, 1, 2, 3, 4, 5, 5 carbon in total, include the COOH carbon. And it must be carbon number 1, lowest number for this carbon because it is attached to the functional group carboxyl. And then this is carbon number 2, substituent amino. Amino becomes substituent because it has lower priority than carboxylic acid. So the name of this compound is 2-amino at carbon number 2, 4-methyl at methyl group at carbon number 4, and then pentanoic acid. 5 carbon in total, 5 carbon longest chain, so pentanoic acid. And this is leucine amino acid. This amino acid name is leucine. And this one, substituent phenyl and substituent amino with 1 CH2. So this is phenylalanine. This is the name of amino acid, phenylalanine. Zwitterion. Zwitterion is a neutral compound that contains both positive and negative charge. So this is zwitterion. The COOH part becomes carboxylic ion. The NH2 parts become ammonium cation. This N receive 1 H. So NH3, the plus is at N. This carboxyl part lost 1 hydrogen. The bonding hydrogen becomes lone pair electron at the oxygen, so carboxylic ion. So this is the zwitterion. Zwitterion is a neutral compound. So this is neutral. Positive on the left, negatively charged on the right, positively charged on the ammonium part, negatively charged on the carboxylic ion. So that's what makes this compound overall zero charge, neutral. It contains both positive and negative charge. However, uncharged neutral form of an amino acid does not really exist. That's why you can see from this table, there's no such thing as NH2 and COOH. It is carboxylate ion and ammonium cation here, because the amino acid of uncharged amino acid does not really exist. Okay, this does not really exist because proton transfer occurs. This hydrogen of the carboxylic acid given to the amino part becomes ammonium ion. This is Zwitter ion. Usually amino acid exists like this after the proton transfer. It contains positively charged and negatively charged. Isoelectric points. Isoelectric point is the pH. When we talk about isoelectric point, it's about pH. The pH at which amino acid exists primarily in its neutral form or in its Zwitter ion. So at Pi, concentration of Zwitter ion at its maximum and the net charge equal to 0. So at Pi, this is the structure of Zwitter ion. pH equal to Pi. When there is Zwitter ion, the pH is equal to Pi. Means negatively charged carboxylate ion, positively charged ammonium cation. Okay, this is when pH equal to Pi. In aqueous solution, in acidic medium, when you put it in acidic medium, you put the Zwitter ion in acidic medium, means there is H plus in there. This Zwitter ion can receive the hydrogen. This H plus will be bond with the oxygen of the carboxylate ion. So it becomes COOH over here. This ammonium cation part remain unchanged. This is in acidic medium. So when in acidic medium, the pH is less than Pi. We know that pH is low when it is acidic. So pH is less than Pi when you see the cationic form in acid. When you see this amino acid form in acid, so you know that the pH is less than Pi. Okay, carboxylate ion is not here anymore. It's COOH. For basic medium, when there is the presence of OH minus, okay, when the presence of OH minus in basic medium, this Zwitter ion, we have the ammonium cation part. This OH minus can receive 1 H plus from here. Can receive 1 H plus from here to form bond with the OH minus. It will become H2O. This part remain unchanged. The carboxylate part remain unchanged, but it will receive 1 H plus from NH3 plus. Becomes water, and this is when pH more than Pi, because we know that in basic medium the pH is high. pH is high in basic medium. So when pH is more than Pi, this is the form of amino acid. Amino acid will become like this in the basic medium. In acidic medium, amino acid will become like this. In basic medium, there is carboxylate ion and H2. Chemical properties of amino acids. So there are 4 reactions of amino acid with HCl, with sodium hydroxide, with HNO2, nitrous acid, and reaction with alcohol. Amino acids, we know that combine many of properties of reactions of both amine and carboxylic acid, because in amino acid, it has amine part and it has carboxylic acid part. So, amino acid can undergo the reaction that amine can react and carboxylic acid react. So, can do reaction with HCl, sodium hydroxide, nitrous acid, and alcohol. For HCl, the amino acid will react as a base, because we know that in amino acid, this is the basic part, this is the acidic part. There are 2 parts in amino acid, acid part, basic part. So when you put amino acid reacts with HCl, amino acid react with acid, this amino acid will become base. It will react as a base. So this NH2 part is the base part. NH2 base. So it will be protonated. This NH2 will receive one H plus from HCl to become NH3 plus. The plus is at the end. And side product Cl minus. Okay, the Cl minus. So protonated NH3 plus Cl minus. This is the product. Okay, it will be protonated. Protonated means it will receive the H plus from HCl. Reaction with sodium hydroxide. Sodium hydroxide is a basic. So, amino acid will react as an acid. When it is in basic medium, it will act as an acid. So, this is the acidic part. The COOH is the reaction site for acidic part for reacting with sodium hydroxide. So, this part will react with sodium hydroxide. This amino part will remain unchanged. So when it reacts with NaOH, the H will be lost. Okay, H plus will be lost, leaving with COO minus and A plus, and the side product is H2O. This OH, it will combine with this H, eliminate this H, combine with OH, side product H2O, and this H is deprotonated. Deprotonated means remove the hydrogen. So the product will be COO minus and A plus. Next, when we react with nitrous acid, okay, nitrous acid, reaction with nitrous acid, we've learned previously in the amine chapter. So we know that in amino acid, there is amine part here. Amine part, if you look at this amine part here, this is primary amine. So when you react it with nitrous acid, the reaction is similar like primary amine. When primary amine reacts with NaNO2HCl under 5 degrees Celsius, it will become very unstable diazonium salt. And the product will be alcohol, alkene, halogenated, but not just alcohol, not just alkene, because it has the COOH part. So the product will be hydroxy acid. This part becomes hydroxy acid, and then alkenoic acid because you have alkene but with the COOH, and then alkyl halide, the one that we've learned in primary amine, alkyl halide. So here it will become halogenated acid. Okay, we have halogen but with COOH. So halogenated acid plus nitrogen gas will be released. Okay, so this is the very unstable diazonium salt. This nitrogen gas will be released, the N2 will be released, and this part will become OH, this part will become alkene part, and then alkyl halide part, halogen part. This is the example. When this amino acid reacts with nitrous acid, it will react as the primary amine. This NH2 reacts as primary amine. We know that primary amine, it will become alcohol, alkene, alkyl halide, nitrogen gas. So this is the alcohol part. Alcohol, here remain carboxylic acid. So that's why the name is hydroxypropanoic acid. Alcohol part, carboxylic acid. Halogen part, carboxylic acid. Alkene part, carboxylic acid plus nitrogen. Next, reaction with alcohol. Excess of alcohol and acidic catalyst often gases HCl to produce ester. Here in amino acid, we have carboxylic acid part. This carboxylic acid part will react as carboxylic acid, reacts with alcohol. This is esterification. In esterification, remove the OH and carboxylic acid, remove the hydrogen and alcohol. In the presence of acid catalyst, often HCl, and the product will be ester, COOR, CO double bond O, and then R, okay, OR here, plus H2O. And this NH, it will not remain as NH2 because it is in acidic medium. You know, then when it is in acidic medium, the NH2 will become the basic part. When you have the base put in acidic medium, it will receive the H+. So that's why it's NH3+ at the amino part. It becomes NH3+. This is the ester with NH3+ and water as the side product. Peptide bond. Amino acids are polymerized by enzymes that form amide linkage, contain peptide bonds. From NH2 of one amino acid, we have amino acid with NH2 part, and another amino acid COOH part. So peptide bond can be formed there. One peptide bond is made by two peptide molecules. Hence, it is called dipeptide. So here, one amino acid molecule, another one amino acid molecule. In order to form peptide bond, in one amino acid molecule, focus on the carboxylic acid part. Remove the OH on the carboxylic acid part, and in another one amino acid part, focus on the amino part. On the amino part, remove the hydrogen. So it will be loss of H2O because we remove OH in carboxylic acid part in one amino molecule and remove the hydrogen part in another amino acid molecule. So loss of water, H2O, and between this carbon where you remove the OH and this nitrogen where you remove the hydrogen, peptide bond will be formed. This is the peptide bond. And you call this molecule as dipeptide because it's from two amino acids. So that's why di. Plus water as the side product because you remove H2O. So water as the side product. So this is how the peptide bond can be formed. To have two amino acid molecules. One focus on removing OH on the carboxylic acid part, another one focus on removing hydrogen on the amino part. And then dipeptide can be formed. Thank you.